Is it the, oh wait, is it when you take the one number minus the other number?
Rate of change. So if I had a straight line, what would rate of change talk about that line?
Slope.
Oh,
Slope. Kick ass.
Yeah.
Right? Now, if I have a function that's not a straight line, so a straight line, of course, the slope is constant. It doesn't matter where you are, the slope is the same thing, correct? So I can talk about the rate of change for the whole thing is a single number. You guys with me?
Yes.
What's different in a situation like this? What would you guys say is the slope right there? Could anybody figure out what the slope is right there? So you're coming up on the roller coaster. What's the slope here? Is it positive or negative?
Positive.
Okay. What's the slope here?
Negative.
So what's the slope right there?
0.
0. I love it. Right?
Okay.
So if you have we're not going to suddenly learn calculus because that's really what this is. But do you guys on this level? Obviously, the slope is constantly changing if I have a curve instead of a straight line. Correct? Is everybody with me?
Yes.
And we can kind of estimate what it would be at places. In calculus, you actually learn how to calculate exactly what the slope is everywhere in a function. But again, we're not going to suddenly learn calculus. So if I'm given a function, let's see, I didn't bring any scrap paper to write up there, did I? Yeah, this room, unfortunately, it's a little better to go on the overhead. What are you? No. No, screw it. Okay, too bad. We'll do it live. If I'm given a function,
Wow.
what's that? Everybody get that reference? And I want to know what the rate of change is between 2 points. So another way to say this is as the crow flies. Have you guys ever heard of that expression?
Yes.
And that just means if you could travel straight to somewhere, how long would it take to get there, right? No matter what the road is doing, what if I could just fly? Okay. So it really still is just calculating a straight line slope. So for example, if I was given the function x cubed plus 2x, and I want to know what's the rate of change from x equal to -1 to x equal to 2. Everybody with me? Like you said, rate of change is just slope. But I just said, and you all agree, that the slope is constantly changing on this thing, correct? But if I just look at, I'm given this function and I just look at the straight line between these 2 points. In fact, can anyone tell me what the 2 points are in this problem? It gave you 2 points, but it didn't write them down. What are the 2 inputs we're using for this problem?
1 and 2.
-1 and 2.
Oh.
So what's one point that we're using?
Is it -1, 0? No.
How do you figure it out?
-1, 2. No.
No, because that's an X.
If I know x is -1, how do I figure out what y is?
Oh, you plug it in.
Plug it in. So what's -1 cubed is -1.
Uh-huh.
Plus 2 times -1. -1 plus -2. -3. All right, what about for an input of 2, what's the output? $12, kick ass. 2 cubed is 8, plus 2 times 2, 4, 8 plus 4, 12. All right, let me stop for a minute. So average rate of change questions, they have to give you 2 inputs. From this input to that input, what is the average rate of change? So from that, you can make 2 points, correct? You can plug each input in and figure out what the 2 points are. If I give you 2 points, everybody in here should be like, sweet, I can figure out the slope. Ask me that question. Ask me a lot of that question, Jeff, please. Right? What's the slope? How do I figure out the slope? Which is the average rate of change? How do I figure out the slope?
2 minus -1.
y2 minus y1 over?
X2 minus.
Yeah. So then it would be 12 minus negative 3 over 2 minus negative 1. Oh, nifty, Jeff. 15 over 3 is fine. Obviously, this picture doesn't go for this problem. I just made a new function. Yes?
That means slope, right?
And mean slope, yes. 11. So in this case, we're understanding this is the average rate of change. How much did the function change over a certain amount of time? So if this is like my profit function, and these are months, then over the course of 3 months, our profit has increased by 5, maybe it's in thousands, $5,000 or something. You guys see what I'm saying? It's how much has the function changed over some interval. Now the formula looks more complicated than this. Of course it does, because were we given that number?
No.
How did we figure that number out?
Plugged it in.
Plugged it in.
The one.
Yeah, plugged in this. I'm going to call him x1. So we plugged in x1, correct? How did we get this one? Plugged in x2, correct?
Yes.
So in general, the formula for the average rate of change is y2, which is f of x2. Right? If you plug in x2, the output is y2. So it's y2 minus y1 over x2 minus x1. It's still just the stupid formula for slope, but what's different is we have to create our points. We have to plug the inputs in that they gave us. We stop there for a minute. So if I give you a function and say, what's the average rate of change from 3 to 5? Well, okay, you plug a 5 in, you get an output, you plug a 3 in, you get an output, and then you just do the slope. That's really all this form. The formula makes it look worse than what it really is. Okay, maybe. What do you get when you plug an x into a function? What's the output? What letter do we give the output? Y. So this really is y2 minus y1, correct?
Mm-hmm.
It just looks different because we're not given y's. We have to calculate the y's first. Okay, maybe. Now, let me get to the actual question that was asked. Because the actual question was asked, it looks worse. So here, this is funny. Yeah, okay. Number 15 doesn't really follow the instructions really. So they give me this. And I want you to, let me see real quick, just go with me for a second, real quick. Let's say I've got a function and I've got an input here, and then I've got an input that's h away from the first guy. So if I give you 2 inputs, can't you figure out how far apart the 2 inputs are, right? So if one input's 3, one input's 5, h would be 2. Is that cool? Real quick, do you guys see how there's an f of x?
Yes.
And do you guys see how there's an f of x plus h?
Yes.
Okay, so y2 minus y1, that's the top, correct?
Mm-hmm.
Now how's the bottom just h? Well, what's the bottom for the slope? Top is y2 minus y1. Bottom is x2 minus x1. So what is x2 minus x1? What's x plus h minus x?
H.
There. That formula is just this formula written a little bit differently. So all I want you to do for number 15, now the part that trips students up for some reason is they freak out because don't have to figure out what this is. Do I know what this is? Shit, yeah, they just told me. They just told me what the hell I was, yes?
Mm-hmm.
What the hell is this? And why is it not a big deal? Don't just add h to the end of it. What do I do with anything I put into here? What do I do with it?
You do what's in there? Like the
Yeah, what's f of 2? How would you figure out what f of 2 is?
You plugged it in.
Plug it in for x, yes? Whatever the hell is here goes in for x, correct?
Uh-huh.
And this is that thing I keep saying about math doesn't care about what's in the problem. The process doesn't give a shit. It's the same process.
So the x plus h is plugged in for the x
Yes.
so that you can actually solve it.
You
Yes.
stop for a minute. That is f of x plus h. It's just so single-minded. A function just says, whatever the hell you put here, I'm going to replace x with it. That's what a function always does. If you're cool with f of 2 being this, you are totally cool with f of x plus h being this. It's the same damn thing, yes?
Mhm.
Maybe? Some of you guys still looking at me like, damn, you have not made sense yet this morning. Okay. Not even a chuckle. I guess that's what you're thinking. I'm sorry. Yes?
So because the formula at the top for on the it's minus f of x, so would we not put 3?
Well, f of x plus h is this,
Yeah.
correct?
Yeah.
And f of x is this, and then I can put this stuff in,
Okay.
right? So this is a nice, that problem has multiple things that I need to think about. So I like to, this is called a construction approach. What does that mean? Didn't we just construct this?
Yes.
So then I can throw it in. Now, what can I do with this? Can't I do some work with this though?
Yeah.
Couldn't I do what to this?
Put the power 2 to the
Foil it.
Foil it. And then what can I do with this?
distribute.
All right, so simplify it, and then whatever you get, you put right there.
Okay.
Because that's what f of x plus h is, correct?
Uh-huh.
Okay, I love you guys so much.
And then you can divide it by or subtract it from that.
And then minus this,
Yeah.
right?
Mhm.
Like terms. All right, so maybe let's do this. All right. So you guys take a minute and simplify this, please. And then if you do that for me, we'll set up the rest of it. While you're doing that, did anybody not get their quiz back? Oh, Romero. Oh, yeah. Oh, Lena. Oh. Oh. Hey. So James. James. Hey. I got a couple Last name? Oh, Munoz. Oh, that's right, that's right. Someday, I remember. And, wait, that's, yeah. Diane L. Yes. I'll always turn original in with corrections. I love it. Is that everybody? Everybody got the quiz back? Okay. All right, guys, how's this going? Anybody got this yet? I'll catch up to you. What'd you get for x plus h squared?
X squared. 2xh. Y.
And then this. Oops.
Wait, y.
Say again, sorry?
I got x squared plus h squared. Where did the 2x come?
Really quick.
Oh.
If I ask you what 39 squared is, and I want you to do it by hand, what would you do? I want you to do it by hand, right? What would you have to do?
39 times 39.
39 times 39, right? Whoa, okay.
Uh-huh.
So if I ask you what x plus h squared, don't you have to write x plus h times x plus h? Same way. And then, of course, you have to FOIL, so you get
Oh.
4 terms, and the middle terms are like terms.
Right.
Okay, be really careful. Exponents are based on multiplication, so they do not play well with addition. They're not based on addition. Does that make sense? Why is this shit so easy? Wasn't this shit easy?
Yeah.
And this shit's hard because what are coefficients based on? They are based on addition. Do you guys agree with me?
Yes.
What is m plus m plus m? 3m. Don't say m cubed. How do I make m cubed? That's m times m times m. That's why exponents work beautifully with multiplication. They suck with addition because they're not based on addition. Coefficients, easy as shit when they're attacking something plus or minus because they're based on addition. Do you understand? Does that make sense?
Yes.
So when you have an exponent and you have a addition, subtraction in the inside, you go, ah, shit. It's not going to be as simple as just distributing. It does not play well. They're not based on that. Okay, maybe.
Yes.
And then we can do 2x squared plus 4xh plus 2h squared minus 3x minus 3a. Oh my God. Is everybody with me?
Yes.
A little bit. Okay. So I can take this entire thing and throw it right there. 2x squared plus 4xh plus 2h squared. You really wrote horribly there, Jeff. Thank you. Minus 3x minus 3h minus this. Okay. All over h. Oh my goodness. So the biggest mistake I see is when I have to minus a chunk of something, I've got to subtract that whole thing. So the negative's going to have to distribute. Yes?
Why is it 4xh? I thought you can't like put two separate variables together. But sometimes
Are you cool with this?
I mean, I know it's possible. I'm not sure how because I know.
Well, okay. So if I FOIL, don't I get x squared plus xh, right?
Yeah, but can't you not combine two separate variables?
Where did I combine two separate variables?
So you're not combining them. You're just putting them next to each other.
Because next to each other implies what operation?
Multiplication.
And that's what I'm doing here. Right?
Okay, got it.
There you go. So I'm just capturing the idea.
Okay.
And of course, if it was x times x squared, couldn't I then combine them? And here I didn't combine them. I just put them next to each other because I don't know what the shit x times h is. Okay. I just happen to have two of them, right? And then I double it, and that's how I got four of them.
Okay.
Kick ass. So then I get 2x squared plus 4xh plus 2h squared minus 3x minus 3h minus 2x squared plus 3x. Do you see anything that cancels?
Yes.
What cancels?
The 2x squared and 3x.
And everything that's left, what's the same in all the things that are left?
H.
They all have an h in them, yes?
Yes.
And I'm dividing by what?
H.
So then what can I do? Since they all have an h,
Take all the h's out.
I can kill an h out of everybody. So then I get 4x plus 2h minus 3. Yes?
That one's too fast for me.
Oh, this step here?
Yeah.
Okay, so I distributed here, is that cool?
Below it, when you simplify.
Yeah, so then 2x squared minus 2x squared dies, right? Negative 3x plus 3x dies. That's all I did.
Oh.
And then I wrote the survivors. So in math, there's always some survivors. You don't want to lose anybody.
Because it takes away one of the h's.
And then the last thing we did
Yeah,
was,
He took away the exponent on the 2
Yeah.
h squared because then that would make it just one h. You should take an h out of each one.
all right. So these are the survivors, correct? And then what's being divided by h? Each of these. So what's 4xh divided by h? 4x. What's 2h squared divided by h? 2h. What's 3h divided by h? Minus 3.
But I thought you can't divide during like addition.
Oh, okay. So if you want to see it all the way out, I appreciate that. Since h is in everything, the step I skipped sort of is I can take an h out, correct?
Oh, okay.
Yeah.
And then what's this operation? Times.
Oh,
And what's
times.
this operation?
Add.
Division.
Oh, division.
So therefore these do cancel because the operations are opposite, correct? That's the thing I told you. If you're about to cross things out, go, are the operations opposite? I see way too many people doing some exceptionally nifty shit, like on a problem like this. This is sort of like what was in it was something like this, I can't remember. You went, okay, those cancel. Oh. Is that okay? Hell no, right? Of course that's not okay, because division does not cancel addition, subtraction. It just doesn't. It can't do that shit. But if I factor the top and bottom, I get multiplication. Division totally kills that. Yeah.
For the other problem on the left side, why did you cross out the one, the x?
Here,
Yeah.
2x squared minus 2x squared cancels.
Oh, that's one?
Negative 3x plus 3x cancel. Yeah. You see that?
You can cancel. Oh, never mind.
Yeah, they kill each other. Yeah. Poor guys. I don't know what their beef is, but.
They don't like copycats.
What's up?
They don't like copycats.
Oh. Oh. They're doppelgangers. Killing each other. Oh my gosh. All right. Okay, now listen. That problem, strange. Do you guys understand if I gave you a problem like this? And again, what did I tell you? The people that are naturally able to break things into parts will have an easier time with math, period. And I told you, I don't naturally see shapes, and so drawing is difficult for me. But for some people, they naturally see the component shapes, and drawing is easy for them. Great. If I want to draw, I need to kind of force myself to learn how to break what I'm looking at into simple shapes. You got to learn that skill. Math. One skill you desperately need to learn is how to see a problem and break it into its parts. So one part of this whole thing is, I got to figure out what the hell f of x plus h is. Let me go do it. Do that part and then throw that stuff back in. Are you guys understanding that? So the question here is, what is this? Okay, here's a chunk of it. Let me do that chunk first, because that's enough to worry about by itself. Do you see what I'm saying? And again, part of it is you guys don't even sometimes understand you're allowed to do that. Is that right? Sometimes you're not, I'm allowed to do that? Well, shit, yeah. I got to figure out f of x plus h is first before I can subtract f of x from it. So I can just do that on the side. Yeah.
It's just a quick question. Why is x plus h in the brackets?
Oh, because that's the interval we're going over, right? So I'm given this function f of x, and I'm going from x to x plus h.
Okay.
That's the interval that we're going from x to x plus h.
And how does that apply in the problem?
How do you mean?
Like, how does that help for the problem?
Understood. For this problem right now, the unfortunate thing is it's just something to do.
Oh.
Now, let me give you a little bit more information. What we've effectively done is we figured out the average rate of change of this function over this interval.
Okay.
That's what that is. And what calculus would do is it would let h go to 0 so that the separation is, so I can figure out exactly what the slope is right at that one point.
Okay.
But again, that's going a little too far. We don't have to worry about that part. Yeah.
When did we find the average rate of change for that problem?
All right, so did somebody write down what's the average rate of change formula?
Yeah.
That's
It's- It's f
X2.
of x2 minus f of x1.
Sure, over x2 minus x1, right?
Yeah, there's
Now,
another one.
real quick, what's the second input on the problem? What's the second input?
X of h.
X plus h, yes?
Yes.
Okay, so that's f of x plus h. What's the first input? X,
X.
right? Is everybody with me?
Yeah.
All right, so what's the second input, right? X plus h, and the first input was x. Is everybody with me?
Yes.
All right, let me stop for a minute. Oh man, I like the board better, but everything in this room is trying to keep you from seeing it. This is the idea of average rate of change, period. That's what this is. This specific problem said, all right, students, let me just give you a shit ton of variables, right? Let me give you x, and I'm not going to tell you what either one is. But again, the process doesn't care. Okay, your input is x plus h? Okay. X, okay. And of course, what does the bottom become? What's x plus h minus x? H, which is exactly, so they sort of did the work for you, to be honest.
Okay. Yeah, I see that.
And of course that made it seem weird because they gave you they shouldn't have even done this, which feels like it would have been harder, but then you would have developed this and understood what it meant. They just gave this to you.
Yeah.
When really, you can see how we get it just following the process. Yes? Oh, I'm sorry. You just have a look like you have a question.
Yeah, then how do we like actually solve it? With numbers?
We're done. That's it. Why? This is unsatisfactory, right? Is this satisfying for anybody?
No.
You wish it was 7, yes? Why am I not surprised we got an answer like this? Because do we know anything specific?
No, it's just very.
The only specific thing we know is what the function is. Do I know what numbers I'm working with?
No.
So of course the answer is going to have variables in it. Because we don't know. This problem, let's see, all of these are weird actually because they all have like, they don't have full numbers here, right? So this entire section should have finished. Look, number 10 is really the same as number 15.
Yeah.
Number 15, they actually did some work for you, which actually made it seem harder because you're like, what the hell's that?
Yeah.
Okay, maybe. Let's do, what else did I assign? Did I assign number 12? Yes. Did I do every third one?
I think.
Yes.
Yeah.
So like number 9. How'd that go? No? Okay.
I don't understand why put this stuff in the brackets. It's just like.
All right.
extra
Let me do this.
information.
Let me do this. And again, let me see. This book, did it give you?
Give it away.
Yeah. Yeah, this book.
Well,
Okay.
that's how you create.
All right, this poor little book. It's free. Poor little book. Let me give you, here's a classic problem. In fact, we just did a classic problem. Let's do another one.
I see
4
what you're saying. That's what you put in.
minus x squared. Yeah, watch. So a traditional problem for average rate of change would say, what's the average rate of change for this function over the interval 1 to 2?
Oh, okay.
So they give me my inputs through the interval of time that I'm looking at.
Mhm.
So this could be from year 1 to year 2. What did our profit do? Are you kind of with me?
Mhm.
Does anyone know what that function would look like if I graphed it? What are the transformations? What does that mean?
Just the the minus.
Yep. What transformation would that make?
um,
There's x squared, right? We all know what that looks like. So what would that do?
Make it go down.
Good. So it's down.
Mhm.
And then this would
Move it up 4.
move it up 4. I love it. So a very rough sketch, nowhere near good enough to turn in for homework, but that captures the idea, correct? Okay. And this works for this problem. The problem doesn't let me make this words. The problem doesn't ask me to graph, but I can still make a rough sketch. That's fine. If the problem asks you to graph, this is not good. This is bad. Okay? I need some scale, I need some shit. But for me, it's beautiful. So now I can see from 1 to 2, can you tell me what to expect for the slope? Should it be positive or negative? Isn't it decreasing over this time period? And of course the 2 would actually be here, but neither here nor there. So I would expect a negative rate of change because it is dropping over time, correct?
Mhm.
So then how would I do this? The rate of change, RFC, is going to be f of x2 minus f of x1 over x2 minus x1. It's y2 minus y1 over x2 minus x1. That's all it is, right? So this would be f of, what's the second input? 2. What's the first input? 1. Second input minus first input.
Okay.
And now you just figure out what f of 2 is.
Yeah.
What is f of 2?
4 minus 2 squared.
4 minus 2 squared, which is?
0.
0. What's f of 1?
3.
3. So you get negative 3. And if this was a profit function, I would say it's in the thousands maybe. So from year 1 to year 2, we lost $3,000. Our profit went down by $3,000 a year. You guys with me?
Mm-hmm.
We're still positive. Isn't it, over this whole range of time, isn't our profit positive?
Mm-hmm.
But this answer tells me it's going down, which is bad. And that's when you call everybody in. You're like, what do we do? Do we put some more annoying ads on YouTube, or is that hurting us? Yes.
Where did the 0 come from?
Oh, when I plug a 2 in, What do I get?
4.
4 minus 4,
0.
0.
Oh.
Yeah. So that's all. Each of these are just saying what output do you get when you put this number in, right?
So you need the stuff in the brackets to plug it in, and then that answer to plug in.
Yes.
To the, yeah.
So every single problem in this section, are you going to get a number answer?
No,
No, because every single problem in this section has a variable piece.
but you do the same thing.
You do the same damn thing.
Okay.
It's going to look worse, but the process doesn't care. Of course, you're like, I know you don't care about me, process. I know math doesn't care about me. This is me throttling math. Just this will help you. Imagine math. This person, you're like, what the hell are you doing? But again, you just go for it. The process doesn't change. I don't want to spend all day on this one problem, right? It's important, but it's not the most important thing for sure. Okay. But it really is just plug and chug shit. So one more thing with this. One more thing real quick. What if my interval would have been, you can do it, Jeff. -1 to C. So this would be f of what?
Oh, sorry.
What's the second input?
C.
C minus f of 1, right? -1
Uh-huh.
over C minus -1. I'm just plugging shit in, right? First step is just mindless. Just plug shit in.
Yeah.
Now you bring your mind into it. Can anybody tell me what f of C would be? What is f of C? What do you put in place of x?
C.
C. So it's 4 minus
C squared.
C squared. Okay. On one level, that sucks.
Yeah.
But I want you to realize on another level, we ain't got to do shit with this.
Uh-huh.
We don't have to figure this out. I can't do it. So I just write that down. 4 minus C squared. Now I got to figure out what f of -1 is. What's f of -1? Three, right? 4 minus 1, 3.
Wait, wouldn't
Over-
that make it a plus?
Sorry?
Wouldn't that make it a plus? Oh. It's
What do you
'cause
do
it's squared.
first?
It's 'cause- yeah.
Exponents.
Yeah,
That becomes +1. 4 minus 1. Yeah.
Yes.
Okay. Right? And then what's C minus -1? C plus 1. So then I get 1 minus C squared over C plus 1. I think you're really gonna like, all right, let me stop for a minute. I just did all the same shit I did when I gave us numbers. I did all the same stuff. The answer is unsatisfactory to a certain degree, because we, as humans, we want 5, right? But of course I'm not gonna get a number answer when I gave it an indefinite interval. It's like, I don't know. I don't know what C is.
And those don't cancel because one of
Now,
the
real
C's
quick,
is squared, right?
I can do one more thing. It definitely doesn't cancel because division can't cancel subtraction
Oh,
or
yeah.
addition. But can anybody see what can I do at the top?
Oh. Foil it.
Unfoil it.
Unfoil it. Gotcha.
The uncola. Yeah. 1 is 1 times 1. C squared is C times C. Plus minus, so what cancels?
The top.
So
Or
then
the-
I get 1 minus, yeah. Okay.
Okay. Would you
Okay.
want us to do that?
Yes.
Okay.
Okay, that is enough of that problem. So again, if it still doesn't quite make sense, obviously you haven't tried those problems yet. Try those problems, come see me, go see a tutor. Of course, you have until tomorrow. Well, you have until the final, to be honest. But I'm not going to put like 18 of these questions on the test. So, okay. All right. Yes.
How big are the tests usually? Does it just matter, or does it just depend on the chapter?
Considering that we only have an hour, what is it? An hour and 20 minutes? So normally my tests have about 25 questions total, so I'm counting like A, B, C, D. So for us, they're going to have to be shorter, so probably 20 at most questions, right? Okay. Yeah.
And then are we gonna take those after the test, or are we just gonna leave afterward?
I was going to be such a smart ass and say, you can do whatever you want. I'm not going to lecture after that. That's all we're doing that day. So you can take the entire time to do the test, and then I'll kick you out, right?
Oh, okay.
Yeah. And then afterwards, you can talk to me if you want to. Yeah, you can do whatever you want to after that. Within reason. Don't break laws. Yes. 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 What's the only thing you're not going to be able to correct? What's the only thing you guys cannot correct? The final. Yay, there you go. How many times can you correct a single thing? Once. There you go. Sweet. I love it. Can you still, if you do corrections and you get them wrong, still can you do it over and ask me if they're right now? Of course you can't always. But I'm just not going to change your grade, right? I've already done it. Yes?
Could we go over 7A and 7D for the practice exam?
Yeah. All right.
So I just kept coming out with weird fakes.
By the way, have any of you guys gone to the Math Study Center yet this semester?
I have. They're amazing.
There you go. Thank you. I hired most of our tutors that we have right now, so I feel very proud of them. They're a really amazing batch of tutors.
My favorite is the guy in the wheelchair.
Oh, Mark, yeah.
Yeah, he's really great.
Mark's been there for a very long time. He's his shirts. I am very jealous of his shirts.
He was like a therapist and tutor in one.
There you go. That's a good summary of Mark. I like that. Okay, so which one are we looking at?
7A and then 7D.
Okay, this doesn't quite capture this idea, but real quick little side note. There was something on the quiz that really troubled me. Okay, real quick. Why can I not say 2 minus 4 is negative 2?
Because of pinball.
Because of who? Because of pinball. That's exactly right.
Yeah.
He's a pinball wizard.
A pinball wizard. You gotta be careful. Don't let those. So, this is obviously subtraction, correct?
Yes.
And subtraction in the order of operations is where?
At the end,
At the end, at the S end, right? What's this operation?
multiple.
Yeah, multiplication comes before addition and subtraction, correct? So you've got to distribute the negative 4 first. So way too many people were doing this. We have got to be past that, right? We must be past that. That can't be something, I really want you guys to understand, that can't be something that feels okay. Writing that hurt me. Writing that hurt me physically. So yeah, you always, one of the very first things you do in an equation is you distribute what you can. Because that frees things up so you're able to put your like terms together, right? Bless you. Okay, I just want to say that real quick because quite a few people made a mistake, and I'm not trying to make you feel bad if you made a mistake. I just want you to really see why it's a mistake and try to make it something you can't physically do again. It just doesn't work. So here, what can I do first? What do I have to do first? Yeah.
4
Yeah, so this would be 3x.
Could you do
Minus
it with
12.
two
minus 12.
at the same time?
And then plus 4x.
Yeah, so the other side you could do.
Yeah,
2x,
2.
2x minus
We use this
12
one.
plus 5.
Is that all right?
Yeah.
Yes.
Okay. Now this problem becomes very strange very quickly. So what do you got on this side when you combine like terms?
7x minus 12.
What do you got on this side?
The
7x
same
minus
thing.
Now, I want you to realize right now you could actually tell the answer, but let's go one more step. Let's get our x's together. When I subtract 7x, right?
Yes.
Now, what I love is you guys profess to hate algebra, but then you desperately try to save the x. Just let it die. Somehow you get to the next level and there's an x left. Where would an x be? What's 7x minus 7x?
0.
There's no x's left, so what do I have on this side? Negative 12 equals?
Negative 12.
Okay, now, how do I interpret the answer when I'm done solving an equation? If I get x equals 3, that means the equation is true, when x equals 3. So this is telling me this equation is true when negative 12 equals negative 12. Does negative 12 ever not equal negative 12? No. So when is this equation true? Always. So what's the answer?
Always.
All real
So
numbers.
would it be the R?
Yeah, so you can actually just write all real numbers. But there's a symbol for all real numbers. And it's an R with an extra spine,
Yeah.
right?
So would
What?
So the symbol for all real numbers is you just write an R with an extra spine next to it.
Oh.
but would you
That's
write,
just the symbol we use for all real numbers, yeah.
would you write X equals the R, or do you just say that it's all?
Yeah, one way to answer an equation is to give a set of answers. So this is valid. If you say X equals, it's sort of wrong because it can't equal multiple things at once.
Okay.
You'd actually have to put X as an element of, but not a lot of us know that symbol. So you could just put all real numbers and circle it and you're fine. You're giving me a
Okay.
set of answers.
Okay.
Yes?
The answer is not negative 12.
The answer would be negative 12 if it said X equals negative 12. Right? So I really want this to make sense. If I do an equation and I get X equals negative 12. So let's say my equation was 2X equals negative 24, right? And I solve it, I get X equals negative 12. That means this equation is true only when this is true. But if I solve an equation and I get this, when is this statement true? What value of X makes that statement false? Does this statement even care about X?
No.
So therefore, the original equation doesn't care about X. No matter what the shit you put in, it'll work. How do you check this then? Pick any damn number you want to, plug it in, it'll work. Yes?
So if you end up getting like if we got like negative 12, 8, would that be no real numbers?
Where are we at? Sorry? Oh, negative 12 equals 8?
Yeah, like if
Beautiful.
it's
Because then that would be, still the answer is, whenever this statement you got is true, the equation is true. So if you get a negative 12 equals 8, that's never true. No real numbers.
no real numbers.
Yeah, no answer. No solution you can say. Yeah.
Okay.
Let me stop for a minute. You guys must have run into equations like this.
Yeah.
The two main types of weird equations are the ones that have no answer and the ones that have every damn answer, right? And the most fundamental way you can make the simplest equation to have no answers, it would be like this. What number do I add 1 to and it stays the same? Is there a number I add 1 to and it stays the same? 0 plus 1 is 1. Is there a number I add 1 to and it stays the same? No, there isn't. If I add 1 to a number, don't I get something that's 1 bigger
Yeah.
than it used to be? So there's no way it could still be the same, correct? So this equation is already bogus. Do you understand what I'm saying? It's a very simple, I don't even have to do work. I can see this is bogus, but if I try to do work, what do I get? So this is math saying, all right, human, you just wrote an equation down, and it is only true when 1 equals 0, okay? And we're like, oh shit, sorry, math, I guess there's no solution to that thing. This is the only way math can communicate to us. It's like, hey, dude, you wrote down this weird-ass equation. There's no answer. This is the only way it can tell us that. Now, what about this? What do you think about this equation? Twice x plus 1 equals 2x plus 2. Isn't that just the definition of distribution?
Yes.
Does it matter what x is then?
No.
So if I solve this, the answer should be all real numbers because it shouldn't matter what x is. So if I try to solve it, 2 equals 2. That's always true. Doesn't matter what x is because x left. X could be anything then. Yes?
So would you care if we just like looked at one of those and was like, okay,
If you
here's
saw
the
one that was this simple,
Uh-huh.
here you could just say, well, that's just distribution. It works for all x's. Beautiful, little tier. Here you say, okay, add 1, it's not going to be the same. I can see it's no answer. Tier, right? So
Explain thought process.
the more you know, the less you should have to do. But you still have to show me how you know. You can't just write down no solution and then no explanation. I'm going to take points off. I need to see something. Work can sometimes be just reasoning out. That's fine. Okay. Oh yeah, this is my other class where I do Egyptian numbers. Okay, don't worry about that.
Cool.
I know.
What class is that? Is that which class?
It's math for elementary teachers.
Oh.
Math 125. Okay.
Yeah, what?
We do D.
Don't worry about that. Sorry. I'm sorry I brought that up. It just happened to be on the other side of that. I'm sorry. D? This guy?
Yeah,
All right.
I kept getting stuck.
I know.
What did you do first?
So I multiplied to get a common denominator.
Yeah, what is this denominator?
X minus 4, x minus 1.
And in this kind of problem, do you see how there's always kind of like hints in the problem?
Yeah.
More than likely, this thing is going to be these two.
Yeah.
Yeah.
Otherwise, it would be a much worse problem than it really should be. So then you can just see what they're all missing. What's this first guy missing?
X minus 4.
So you give it to him. I like it.
And then x minus 1 for the middle one. Yeah.
Of course, I got no room here, but okay. So then on the bottom is going to be x minus 4 and x minus 1. What do you got in the top here?
5x minus 20.
5x minus 20.
And then
Minus
2x plus 2.
Oh, I see. That's where things went wrong. What's 2x times x?
2x squared.
And then 2x times negative 2x times negative 1 is plus 2x equals 3 over stuff. Right? Is that?
Okay.
And now that I got the same denominator everywhere, what am I able to do?
Cancel.
Kill him. So I can multiply both sides by this and it dies. And again, why is a fraction dying? Because it's in an equation. I can't just, if I have a fraction just standing there, I can't kill it like this. Right? And you're like, I can erase it, but it won't do you any good. And now you got just this equation. What is it about this equation that tells you how to solve it?
You combine your like terms and then factor.
Why factor? What do you want to get it to equal?
X.
No.
0.
0, because I see a higher power than 1 on one of my variables, right?
Oh,
So
right.
whenever you see an x that has a higher power than 1, you want to get everything on one side, get it equal to 0, and then factor. Now, let me stop for a minute. I love the fact that some of you guys have very expressive faces. Some of you guys are like complete poker players. I get like nothing.
This like whole middle section.
Don't talk bad about the other section. They're fine. But again, you would kick my ass in poker. That's all I'm saying. Please tell me if I lost you somewhere. So from the very beginning, I could see, if I break this guy down, I can see what the other guys are missing. So there's a really beautiful idea here. You just give them what they're missing. Sounds like a life lesson. So this is x minus 1, x minus 1. I'm not going to start talking politics somewhere. So then what's this first guy missing? An x minus 4, correct? Is everybody cool with this idea?
Yes.
If I make all the bottoms the same, since it's an equation, I can multiply both sides by anything I want to except 0. So I'm going to multiply both sides by x minus 4, x minus 1, because that's going to cancel all the bottoms out, right? So then I have a much, much better equation. So if I ever give you an equation where there's fractions in it, be there variables on the bottom or not, you make all the bottoms the same, because then you can kill them. You can multiply by that. Yes?
But that's only if it's addition and subtraction, right?
That's if it's in an equation.
Oh, okay, so it doesn't matter.
The multiply both sides step can only happen, obviously, if it's in an equation.
Okay.
Right? So what I'm saying is, I'll get people, do I have a problem like this? I'll get people get this problem. Can I multiply this and kill the bottoms?
No.
Why not? There's no other
Like terms.
there's no other
Oh.
side. It's not an equation.
Oh.
What allows me to multiply in this problem? The fact that I have two sides and I can multiply both sides, correct? That's what allows me to do that. If I do not have two sides, I cannot multiply. That's like saying 2 sevenths minus 1 sevenths, and then going, okay, let me multiply by 7. 2 minus 1. So 2 sevenths minus 1 sevenths equals 1? Does that make sense?
No.
Okay. So you're only allowed to multiply or divide or do something adds when you have two sides. Then you have something to balance it out. You do it to both sides.
And so what would you do there? Reciprocal? Like,
No. Here you would just freaking subtract.
Oh no, G.
Oh, gee.
Do you
Oh.
take the reciprocal and then?
When do you reciprocate something?
Division.
Division, yes. So here I just do exactly what we just did. I just won't be able to get the bottoms gone. I won't be able to kill them.
Okay.
If I factor this, what do I get?
X. Yeah, X plus 3, X minus 3.
And if I factor this, what do I get?
Oh, yeah.
So what's this guy missing? What's he missing? He's got.
An X plus 3.
Yes! Right? So you give it to him.
I thought you can't do that because it's equal.
All right. Okay.
Well, but see, now it's multiplying.
All right. I cannot multiply. I really want you to understand. Let me write it up here. I love you guys so much. If I just have this sitting here, right? That's what that is, correct? If I multiply top and bottom, which is what I was about to do here, right? Give it what it's missing. What did I actually just multiply by? What is this?
1.
1. I'm always allowed to multiply any damn thing I want to in the universe by 1. There's nothing that can stop me from doing that.
Just can't add things on.
Then what was the thing we weren't allowed to do?
All right.
Add.
On this problem, I just straight up multiplied by, where'd it go? By the bottom. I just straight up multiplied by the denominator to kill it. That is, so example, again, if I have 2 sevenths minus 1 sevenths, I cannot just multiply by 7 out of nowhere and make it 2 minus 1. I can't, of course I can't. Is 2 sevenths minus 1 seventh equal to 1? Is that true? No, of course not. 2 sevenths minus 1 seventh should be very small, right? It can't be 1. So I am, but, all right, if I have 3/5 minus 1/15, again, I'm not allowed to multiply by 15 and kill the denominators, but what can I multiply this guy by? 3. And didn't I do it to both sides? Top and bottom side? Completely legal, because what did I actually just multiply by?
1.
1. I did not change the value of the number, I just changed what it looked like. Yes?
Yeah, because you never added on whole.
That's completely legal because I did not change the number. It's not a different number. Would you agree with me that 3/5 does not equal 3?
Yeah.
Yes, so if I take 3/5 and I just multiply by 5, I have completely changed the number. It's not the same number anymore. Is this the same number as this? Is that the same number as this? Totally. 3 divided by 5 is the same thing as 9 divided by 15. They're the same number. But I've just changed it so I can see how many 15s it has. So now it's like terms. That's all I did. So I am not allowed to multiply a fraction to kill its bottom unless it's in an equation, because then I can do it to both sides. Okay. Anything else on there? Yes.
I was just about to say.
So what's E is
Oh, on that side?
nifty. What do you do first, always, when you have radicals in your equation?
Square it.
That's not the first thing you do. Nope.
You have to get, don't you have to, isolate them?
Good. And I've got 2 radicals, yes?
Yeah.
All right, so pick one and isolate it. So I'm going to isolate this first one because then I could just add this one over. Is that cool? You guys with me? So then I've isolated this guy. Now listen, does this make sense? If I have 1 square root in an equation, I'm going to have to square once. If I have 2 square roots in an equation, I'm going to eventually have to square twice to kill each one, right? So let me get one of them by themselves. So can I kill one of the square roots now?
Yes.
Yes. So if I square both sides, I kill this one. How do I do this side? How do I square anything? Multiply by itself. Good. All right, so you got a FOIL. And this is where, again, I totally get this. Some of you guys would see that and just sort of give up. But you know how FOIL works. Okay, are there gross things inside? Yes. But the process doesn't change. Yes.
So you have to put the radical before the -5.
No, you don't. I just like to do that because I would much rather have like 7 minus 5 instead of -5 plus 7. It just looks cleaner. But you don't have to. Of course not.
So you could have -5 times the square root of.
Definitely not.
4.
Are these two multiplying? What did I do to both sides?
You just
Add
add
Add it. So I can't change that into multiplication.
Okay.
So this I could write this instead of this. I could write it as this. That's the same thing, of course, right?
Okay.
Sorry, you couldn't even see it. I like how you just like, yeah, whatever you're saying.
Okay. Okay.
Okay.
All right.
Oh, I see.
Okay. All right. So help me out. Do you guys remember what the square root of something times the square root of that same thing is?
Oof,
It's just what's in the
Oh,
radical, isn't
yeah,
it?
yeah, yeah.
Yeah, half of x plus 4 times half of x plus 4 makes a whole x plus 4. Don't I get -5 of these, minus another 5 of those when I FOIL it? -5 of these, -5 more of them.
Yes.
So don't I have -10 of these?
Mhm.
And then I get -5 times -5 is plus 25. Now again, you guys are writing frantically. I've got the answer key. So I've got all this stuff written out. So let's go down here. So I get x minus 1, right? X minus 1 equals all this business. Is this cool? 4 plus 25?
Yes.
It's 29. All right. What do you see cancels immediately, which is great? What cancels? Both sides. Because I can't do anything to either side now, right? But the x's cancel. Is that cool? I can subtract x from both sides, right? They cancel. Bam, bam. And then I could subtract 29 over. Is that cool? So then I get -30 equals -10 times the square root of x plus 4. How many go ahead.
So the x plus 4 is back in the radical. Why is it back in the radical?
What do you mean back? So right up here, right up here. Square root of x plus 4 times square root of x plus 4 is a whole x plus 4. Awesome.
Yeah.
But don't I get -5 radical x plus 4? Minus another 5 radical x plus 4? Don't I get -10 radical x plus 4?
Yeah. But
Okay.
Where did the x plus 4 that's outside of the radical go?
Square. What do you mean go? So what's 25 plus 4? 29. Okay, and the x is still here, right? All right. So right here, all I did was x plus 4 plus 25 is 29. So there it is.
You just combined the.
Yep.
Okay.
And then I subtracted x over, right?
Okay.
Okay. So this got a problem where there's 2 radicals in it. It should make sense to expect to have to square twice. If I square once, I kill one of them. That's awesome. I still have one left right there. So then what am I trying to do now? I'm trying to get him by himself. What's one step I could do to get that thing by itself?
Square both sides.
No.
Oh,
What's still with that? Do you divide by
10?
-10?
Oh, yeah.
3 equals this. And now I can do what? What'd you say?
Tens.
Square?
Square. So I finally get x is 5. Oh boy. And of course you have to check that. You have to plug it back in to make sure it actually works. And the great thing is, I'm not sure how you feel about this, it doesn't work. So you get no solution.
How'd you get the -30?
Here? Oh,
Yeah.
there's a -1 here, right?
Yeah.
Subtract 29 over. Okay.
So with these, you have to plug it back in because it's one of those things where you get a number, but then it's just not.
Yeah, I really want this to make sense. Can you guys tell me, would there be an answer to this equation?
It would be I.
Yeah.
No, it wouldn't.
Oh.
It wouldn't be.
You would
No,
square
wait.
those.
It's impossible.
Yeah.
So there's one little thing that I haven't directly addressed, but How many answers are there to this? 2 of them, right? What are they?
3 and -3.
Yeah, 3, -3. This is what is called the principal root. The principal root is defined to be the positive root. If I wanted the negative answer, I would have to specifically do that. So the answer to a square root cannot be negative. So let me ask this one again. What's the answer to this? No solution. I love it. If you square both sides, though, don't you get x equals 1?
Yeah.
When you square both sides, you lose if something was negative or not. Does that make sense? Everything, if you square something, it's not negative. If it was negative, it isn't anymore. We lose that information. So how many times did we square in this problem that we just did? Twice. Holy shit. So there's 2 times we lost if something was negative before. So we got an answer, but it doesn't work way at the beginning before we square twice. Yeah.
So we could have just looked at it equal -5.
No. Why can't you just, I appreciate that. If it was that, I could stop right there. But can you guys, what's the square root of 4?
2.
And what's the square root of 9? So what's the square root of 4 minus the square root of 9? 2 minus 3, -1. So is it possible for the difference of 2 square roots to come out negative? Yes, okay. If the problem would have been the square root equals a negative, you could have right there just not done any work and said no solution because the square root can't come out negative. But can the difference of 2 numbers be negative? All day long. Okay. Yes.
So for me, just a quick question. You don't have to like go through the whole thing. I just don't know what would be the first step. I know it has to break up into 2 parts, but I'm having trouble like starting those types of problems.
Yes.
Because C is easier. You can just like subtract the 5.
C is easier because it's an equation, right? This one's an inequality.
Yeah. I just really don't understand solving inequality.
So the 2 cases are either this is already bigger than 2, or this is less than -2. So one case is leave everything alone, the other one is change the sign, and it should kind of make a little bit of sense. What happens if I change the sign in an inequality? Doesn't the
You
sign
have to
flip?
the
So that's exactly what happens, right? So one case is it's already bigger than 2, or it's less than -2.
And then you just solve those.
Then I solve this one and I solve that one. Yeah.
Okay. And how do you treat the inequalities? Do you treat it like it's an equal sign?
Solving inequalities is exactly like solving equations,
Okay.
except if you divide or multiply by negative, the sign flips.
Okay.
Do not replace this with an equal sign. I'm seeing people do that.
Oh.
I really want that makes. If you solve an inequality and you just replace the inequality with an equal sign, and you divide by a negative, you're making yourself have to keep track of, okay, which way is the sign facing? You can't just bring the sign back in. Do you understand what I'm saying?
Yes.
Do not replace an inequality with an equal sign, because if you divide or multiply by negative, right then you should flip the sign, and you're going to forget. Of course you are. Because who's going to keep track of that kind of shit, right? So just don't do that to yourself. Yeah.
You said it's only multiplying or dividing by a negative.
Yeah, multiply or divide by negative. That's the only thing that'll make the sign flip. Exactly.
Okay.
Exactly.
Okay.
Yes.
Why'd you flip it there? Without multiplying by
Okay. So.
Because you switched the sign.
So this is
Because it was a positive 2 and then it was a negative 2.
I've talked about this in a few different ways. So again, give me a number bigger than 2.
3.
What's the absolute value of 3?
3.
Is that bigger than 2? Yes. Give me a number that is smaller than -2.
-1.
No.
Oh. -3.
-3. What's the absolute value of -3?
3.
Is that bigger than 2? Yes. So if the number inside is greater than 2, it's trivially true. Because of course the absolute value is still going to be bigger. If the number is smaller than -2, the absolute value makes it a bigger positive number. Now, that doesn't really satisfy your question. Real quick, remember this?
Yeah.
Right? Again, what does that say? The absolute value only does something if the number is negative, correct? Absolute value of 7 is?
7.
Did the absolute value do something to 7? No. What's the absolute value of -7?
7.
Did the absolute value do something to -7?
Yes.
Yes, so it only does something if the number is negative. That's all that says.
Okay.
Are you with me?
Yeah.
What's it do if the number is negative? It changes its sign. So, absolute value of 3 plus 5x equals, let me do this one first. 3 plus 5x, if 3 plus 5x is bigger than or equal to 0. It leaves it alone if it's already positive, or it changes its sign if it's negative. I'm showing you way more than you have to see, but I do appreciate the question, and I showed you this sort of once before. So the absolute value of 3 plus 5x greater than 2. This is either it leaves it alone, or it changes its sign. And that's what. So what do I do then to kind of circumvent that entire thing? Look what happens if I divide both sides by -1. What happens?
Oh, okay.
You get that second case. So the way I try to teach it is just sort of go straight to the idea.
Right.
One case is everything stays the same. The other one, the sign changes, so the sign flips, the inequality flips. This is behind the scenes of why that actually, like, mathematically works.
Okay.
You can sort of see why I don't necessarily want to go this route, but the question, I love it. That's the kind of question I live for. Why the shit do you do that, Jeff? Yes, I know you didn't ask it like that, but still.
So then, once you separate it into the two, are you just solving for it?
Yeah,
And
then
then
there's
those
two
other
separate,
two-
easy, relatively easy inequalities, right?
Okay.
Just subtract 3, blah, blah,
Okay.
blah. Yeah.
Cool. And you would do the same thing with C then?
Sort of,
Or
except
is
it's
that-
easier.
Is that different?
It's a lot easier because there's an equal sign. But what's the very first thing I should do in part C?
You have to.
Take away the 5.
Beautiful.
Yeah.
So in general, in algebra, in mathematics, real quick, let me show you a few lightning round problems.
So then would the plus just go away then?
Say again?
Would the plus just go away then? Because a positive times a positive is a positive.
Yeah, so the
and
plus
a
sign,
positive
I
times
mean,
a negative is
again,
negative.
that you're basically asking me why don't we write a plus in front of 4? Because we assume it's positive, right?
Yeah,
But we have to put a minus,
yeah.
right? So I still get people that are doing stuff like this, 2 minus x equals 8, and you subtract 2, and suddenly the negative's gone. Shouldn't there still be a minus here?
Yeah.
Okay, so be careful about
Yeah,
that.
but, so,
So of course if you subtract 5, so let's,
does the absolute, I guess what I'm asking is, does the absolute value serve as a multiplication?
absolute
Like, so
value
when-
is
Oh, I see
So
what
when
you're
you
saying.
take away, so when you
absolute
take away.
value is one step up from parentheses.
Mhm,
So absolute value is like parentheses. You do inside the absolute values first.
mhm.
Parentheses don't tell you to do a damn thing. They just group shit. Absolute value has its own thing it's asking us. So for
Okay.
example, if I had this problem, what would I do first?
Exponent.
Yeah, I do the inside
Excellent,
first,
yeah.
right? 4 minus 7 plus 4 is 8 minus 7 is 1. Absolute value. Now I do the absolute value, right? So they
Okay.
act like parentheses in the fact that whatever's inside of them you do first.
And then it,
But then
it's-
they have their own thing that they want to do
okay.
after you've simplified the inside.
But
And a
then if you
problem like
had-
this, I can't do shit inside, right?
But then if you had something on the outside of the absolute value,
Yes.
is it then a multiplication?
Totally, yeah.
Okay.
So if I had this, read what operation is this understood to be?
Multiplication.
So it's just like this, it's exactly like this,
Okay,
except the absolute value, instead of just sort of disappearing, it has its own thing it wants to do. It wants to make this become.
a positive.
Now, what mistake did I just make? It just made a mistake.
You
It's
changed it to
not
addition.
adding.
I know, so in a few of you guys' quizzes, I put down there subtraction can't become multiplication, right? That's some next level shit. That's some, you know, I normally would put like a Harry Potter joke in there, but I don't.
That's what I did wrong on that one.
J.K. Rowling has some issues. So what should still be here? What operation?
Negative.
What operation is it?
Multiplication.
Yeah, yeah. Again, all right. What does it say? Doesn't it say, what, read this to me.
2 times the
This,
absolute
right?
value of negative.
What is this?
4.
4. So then this should be, you can write this if you want to. You need some symbol that means multiply.
Okay.
Because that's the operation, correct?
Okay, so
Okay.
so basically, doing the absolute value is doing what's in the parentheses.
But positive.
Sort of,
But
yes.
make it positive, yeah.
Like you're.
Yeah. So you do what's inside of these, and then the absolute value wants you to do something also. Yes,
Okay.
yes. Okay. So real quick, this problem,
Finally grasping. Chapter 1.
this problem versus this problem, right? Guys. Those 2 problems. In fact, I can make a third one. Let's see. 5 plus 4 minus 2x squared. They all have the same first step for the same reason. What's the first step on each one?
Do what's inside.
No. Well,
No, you
yes,
subtract
but I can't
the
do
five.
it.
Subtract the 5.
Subtract the 5.
I gotta
Right.
isolate the term that has my variable in it,
Right.
so then I can attack it directly. So in this case, I want to isolate it, so then I can write my 2 cases. Correct? This case, I want to isolate it, so then I can do what?
Square root.
Square root.
Okay. And then this one, I want to isolate it, so then I can do what?
Square root.
Square
Root.
root it. Plus or minus? Okay. Right?
Mm-hmm.
So basically, most equations, some equations are simple where you just distribute, get your like terms together. Other equations, you find where your variable is, and you get that piece by itself, so then you can free your variable up. It's stuck in an absolute value, it's stuck in a square root, it's stuck in a square. You want to get it by itself, so you can attack it directly and get it free, right? Yes?
So then so the one up there, with the, yeah, that one.
Yes.
So you end up with 2 cases, right?
Yes. So one case is always, if that number is already 7,
Uh-huh.
isn't that just true trivially?
Yes.
Right? If that number is already 7, the absolute value is 7, 7, great.
Yes.
Or if this number is, what other absolute value is 7?
Negative 7.
Yeah, so if that number's 7
Okay.
or if that number's negative 7, either way, that works.
Okay, so it's always the number that's outside of the absolute value that's going to be plus.
And again, to go
minus.
back to what we said before, just real quick,
Okay.
you don't have to write this ever, but the absolute value either leaves it alone or it changes its sign. But instead of
Okay.
doing that, I just divide both sides by a negative. So, and this makes complete
okay.
direct conceptual sense. Either the
Okay.
inside is 7 or the inside is negative 7.
Right.
Now,
That's what
do
that
we have,
means,
do
right?
we have to show you that we did the division and everything, or can
No,
we
no,
just
no, that's
write
what I'm
it?
saying. I teach this so that you don't have to like work directly with this.
Okay,
You just, if you isolate the absolute value, either the thing inside is 7 or the thing inside is negative 7.
okay.
And then you just solve each little piece, yeah.
And the absolute value always breaks it up in 2.
2 cases.
Okay.
Be it equation or inequalities, there's always 2 cases. Why are there 2 cases? Because there's 2 places an answer could have come from.
Right.
Mhm.
If it's 9, it could have been 9 or negative 9 to begin with. So there's 2 possible places it could have come from. That's why there's 2 cases. Okay.
Oh, so for on the front for 2C, does that mean there's going to be 4 cases then?
Huh?
Oh, I see what you're saying. No. This is not an equation, right?
Oh, yeah.
Oh, I'm
yeah.
not-
It's just a straight up computation problem, right?
Okay, got
So you simplify this to a number, simplify that to a number, and then you put,
Adam.
yeah.
Okay.
All right, let me do this. Let me give you guys the answer key, so you have a little bit of time to look over it, find out where I made mistakes.
Oh, yeah.
So I really want to be careful because I have students who are going to be a little more comfortable asking questions and students not so much. If you have a question, just put your hand up there, let me know. If you don't want to ask in class, just come see me in my office hours, right? Go see a tutor. I am answering anything people are throwing at me. So if you're sitting there going, I'm never going to get in, just put your hand up. I'm totally going to come to you. I'm not going to
I don't need more.
let anybody like take all the time. But I'm going to focus on people who are asking me questions, right? So, how's everybody else doing? You guys? I want to point out something. Most of the questions you guys have asked have been on the hardest problems on the practice test, which are good. Right? Those are some of the harder problems. How is everybody else doing with some of the other ones? You guys notice that A and G are basically the same kind of problem, right?
Yeah.
I don't know why I did that, I just did. Don't read into that. Don't think that means I like that kind of problem. It's going to be more of them. No, I just happened to put two of the same kind. So let's kind of walk through this a little bit. How much time do I have? I've got like a whole 2 minutes. No worries. How do you guys feel about this section here? And I think these problems are obviously the hardest. What about F? We didn't get a question about F. That's the place where you definitely don't want to do what?
Factor. No.
Oh gosh, you
That's
definitely
where
want
to
to.
do.
You don't want to
That's where you want
cancel
factors. That's
stuff
where you don't-
because division cannot cancel subtraction or addition, correct?
Right.
Yeah.
Okay, so
Yeah.
you gotta kind of like do one of these. No, kill the x's. No, you can't. Okay, yes,
Is it okay if I have a question about something else?
yeah, totally. What you got?
Number 8, graph the base function.
Oh yeah. Okay, so there are a couple of them I said we're gonna do together. Let me do it in the 48 seconds I got left. This one, for example, and the one on the front was this guy. So let's do this one first. And I think the problem. Oh, let me just give us a quick. I got no time for this.
All integers are round.
So the picture from the book basically looks something like. Shoot, I should copy it down. It was page 202, right?
No. Number 52.
I wanted to do this together since it was the most recent stuff we did. All right, so 53 looks like this. I'm just gonna copy it down. Yeah. Okay. So here's what the original function looks like. And it does go, yeah, it sort of goes through, okay. That's what the original looks like. What are the transformations? How many transformations are there in this statement?
3.
3. What's the one you want to do last? Up 1, I love it.
Yeah.
Order operations, rules a day. The other two doesn't really matter. What are the other two? Let's see, what do you guys see first? What's the other two transformations? What's that negative do? Flips it over.
The x-axis.
Yes. How do I know? Because whatever the outputs were, they're the opposite. So whatever the outputs were, they're the opposite. So it's going to do like this.
Yeah.
Right? Also, if it's outside, not with the x, it's up and down. So that's why it's going to rotate like this.
It's,
So it's reflect across the x-axis.
and then it goes right 2.
Careful.
Oh, up 2.
No.
Left
To
2.
the left.
Left 2.
Wait, I thought left was negative.
Every number I
No, it's
plug
the
in,
opposite.
every number I plug in, remember this about the bar? If it costs $8 to get in the bar, but your friend gives you 2 right at the door, how much money do you have to actually bring? 2 less. So since it's adding 2 to me, everything can be 2 less than they used to be. So, we do this real quick and then I'll let you guys out, but and to be honest, it's the end of class, so you could just walk out if you wanted to, but I appreciate you're not. So then I would take reflect it across the x-axis. Now watch this. So I take every point and I just reflect it. So 1, 2, 3. So 1, 2, 3. So there. Reflect it. Reflect it. Okay. I'm not done yet, right? So if you wanted to, you could do multiple steps. Then what do I want to do with each point? What's the next thing I want to do? Left 2. You with me?
Yeah.
Let this be nice. If you could identify the transformations, you just apply them, bam, bam, bam. To what? To the easiest points to see. So I reflect every point, then I go back 2 for every point, back 2 for every point, back 2 for every point, right? So now I got to remember which is why multiple colors is a good idea. So let me make these bigger so I know where I am at the moment. And then I want to go up 1, right? You guys with me? So let me put a little, let me put a little X. Up 1, up 1, up 1. So now I just fill in the shape again. The shape is like this. So I just took that shape and I flipped it, moved it back, moved it up.
I see.
And you could do multiple graphs if you wanted to, right? So you could bring some graph paper. I will give you like one of these graphs on the specific problems, but you can bring graph paper and do it on that if you want to.
Quick question, how did you know that it was reflecting across the x-axis and not the y?
So again, if it's inside with the X, that's left and right. So watch. If it's in with the X, it would flip this way, left and right.
Uh-huh.
If it's outside, it flips up and
Like,
down.
Yeah.
So I know it's going to flip this way.
Oh.
So in general, in with the X, left and right. Outside, up and down.
With the transformation, can I kind of just
Okay.
like remember the rules?
Okay.
You guys can head out, but I'll just list these transformations for you. This would be right 4, right? This would be double. And then finally, you would go down 2. So I'll probably figure out how to put that up on Canvas for you, okay? Yeah.
I have a question on this.
Oh,
Was I not supposed to do this since it's an equal sign?
yeah, it's an equal sign. So
Okay.
inequalities are what allows for all these other answers. Equals is very specific, so it's just that number, and that's it. Yeah.
And
Okay.
for this one, for these,
Oh yeah.
was I allowed to like do that with the 9?
So here's the problem, real quick. Whatever I do to one side, I have to do to the other side, right? So if I had like this, for example,
I'm just starting this way.
Okay.
3 plus 2 squared away. If I square this side, I must square this side, right? I can't square each piece. I have to do it to the whole side, right? So you're not allowed to go in and just square individual pieces. So what you actually have to do, and this is why, if I squared both sides right now, that would suck, because then I have to FOIL this. See that? So that's why the first thing you want to do, like we were talking about earlier, is there's my variable. Let me get it by itself first. Then I can square both sides without having to FOIL anything, because that'll just kill that. So that's why the first step is isolate the radical, because otherwise you'd have to square the side and FOIL the whole thing out.
And for this one, is there more to do with that? Just not back. I thought it was back.
Well, it's equal 0. Solve. So you got it factored, so what are the answers? What makes them 0? What makes that 0?
3, 7.
Those are the answers.
Oh.
Yeah, so when I say solve, you know you're done if you get x equals something, or all real numbers have solution. But you need to tell me what the answers are, yeah. So it's more than a factoring problem because it's part of equation. So I'm expecting numbers for what x.
So if I correct all my mistakes, what is my grade gonna be?
You can get 7 points back.
Oh, okay.
Yep.
I
Oh,
didn't get
sorry.
mine.
Turn you off. Very